On this Ram 1500 Classic with the 3.6 Pentastar, P0330 is a knock sensor 2 circuit fault. In plain terms, the PCM is seeing the knock sensor signal out of the range it expects. The driver may only notice a MIL, but depending on how the PCM reacts, there can be drivability changes. The fault area can be the knock sensor 2 signal circuit, the return circuit, the sensor itself, connector problems, or, after the circuit and connection checks are exhausted, the PCM. Start with the basic system checks first, then follow a structured diagnostic approach so we do not jump straight to a sensor or module. Before chasing the circuit, make sure you can reproduce the operating conditions. This monitor runs with engine speed above 2000 RPM, battery voltage between 7.5 volts and 15.8 volts, and barometric pressure above 75.2 kPa. The PCM sets this fault when the knock sensor input is above 4.8 volts or when it is less than 0.2 volts with engine speed above 2000 RPM. If needed, use the captured operating conditions to get the vehicle back into the same situation that set the code. Start the engine, then test drive or operate the vehicle under the monitor conditions. Use the scan tool to read and record the codes. If P0330 is active or pending, continue into the circuit checks. If it is not active or pending, treat it as an intermittent condition and focus on recreating the fault instead of forcing a hard fault test path. With an active or pending fault confirmed, turn the ignition off and disconnect the knock sensor 2 harness connector. Turn the ignition on and measure voltage on the K242 knock sensor 2 signal circuit at the knock sensor harness connector. If that voltage is above 5.2 volts, repair the K242 signal circuit for a short to voltage, then verify the repair and confirm the code stays gone. If it is not above 5.2 volts, move on to the resistance checks. Before checking continuity back to the PCM side, turn the ignition off and disconnect the PCM C2 harness connector. Install the GPEC diagnostic adapter 10436 on the engine harness side of the PCM C2 connector. Do not connect the adapter to the PCM, and do not probe the PCM harness connectors directly. Probing those terminals can damage them and create a poor terminal-to-pin connection. Measure resistance in the K242 knock sensor 2 signal circuit between the knock sensor harness connector and the GPEC adapter. The decision point is below 3.0 ohms. If the signal circuit is below 3.0 ohms, continue to the return circuit. If it is not below 3.0 ohms, repair the K242 signal circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Next, measure the K924 knock sensor 2 return circuit between the knock sensor harness connector and the GPEC adapter. Again, the decision point is below 3.0 ohms. If the return circuit is below 3.0 ohms, keep moving through the short checks. If it is not below 3.0 ohms, repair the K924 return circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Now check continuity between the K242 knock sensor 2 signal circuit and the K924 knock sensor 2 return circuit at the knock sensor harness connector. If there is continuity between those two circuits, repair the short between the signal and return circuits, then verify the repair and confirm the code stays gone. If there is no continuity, continue to the short to ground check. Check continuity between ground and the K242 knock sensor 2 signal circuit at the knock sensor harness connector. If there is continuity to ground, repair the K242 signal circuit for a short to ground, then verify the repair and confirm the code stays gone. If there is no continuity to ground, the circuit checks have not found the fault, so the next step is the sensor retest path. After the voltage, open resistance, signal to return short and short to ground checks have passed, replace knock sensor 2. Reconnect the knock sensor 2 and PCM connectors, turn the ignition on, erase the codes, and operate the vehicle under the captured conditions or the monitor conditions that set the fault. Read the codes again. If P0330 is not active or pending, the knock sensor 2 replacement repaired the fault. If it is active or pending, continue into the connector and harness inspection. If the code comes back after the sensor retest, disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect the harness and component connectors closely. Connector seating, locks, corrosion, water intrusion, weather seals, bent terminals, overheated or discolored terminals, push-back terminals, spread terminals, and terminal tension. Repair anything found. Then reconnect the PCM connectors, inline connectors if equipped, and component connectors, making sure everything is fully seated and locked. Erase the codes, operate the vehicle under the monitor conditions, and read the codes again. If P0330 returns after the connector and harness issues have been checked and repaired, replace and program the PCM. If the code does not return, the wiring or poor connection problem has been repaired. Keep verification separate from testing. After any repair, clear the code, run the vehicle under the conditions that set the fault, and confirm the code stays gone. Takeaway: diagnose P0330 as an electrical circuit fault first. Prove the signal and return circuits. Protect the PCM terminals during testing, and only move to the sensor or PCM after the earlier checks support it. For more diagnostic training, visit Diagnostics.com.